Welcome to my presentation. In this presentation, let us try to solve linear equations of the form ax plus b is equal to cx plus d. Let's say we have an example of this type. We want to solve 3 times 4a minus 1 is equal to 4 plus 5 times 2a minus 3. We want to solve for a. We have a's on the left hand side of the equation and on the right hand side of the equation as well. So to do that, let us break it down into these different steps. Step number 1, we will distribute the 3 to every one of the terms inside the set of parentheses here. So 3 times 4a and 3 times 1. 3 times 4a is 12a minus 3 times 1 is 3. That is the simplified form. We have used the distribution property to distribute the 3. On the right hand side, we have 4 plus, we will distribute the 5 to every one of the terms in this set of parentheses. 5 times 2a, 5 times 2 is 10a, like that. And then 5 times negative 3 is negative 15. So on the left hand side, we have nothing to simplify. But on the right hand side, we can combine these constant terms, 4 and negative 15. 4 plus negative 15 is going to be equal to negative 11 plus 10a. That is what we have. Since we have a's on both sides of the equation and constant numbers on both sides of the equation, we can either eliminate, we can get rid of the constant numbers first or the a terms, but our intention is to get the a terms to one side of the equal to sign. So let's use our addition property and then simplify this some more. In step number 2, we're going to say we will eliminate the 3 on the left hand side. So we're going to add positive 3 to both sides of the equation. Positive 3 to both sides of the equation. And how does that look? 12a minus 3 plus 3 is equal to negative 11 plus 10a plus 3. We have added positive 3 to both sides of the equation. And when we do that, the negative 3 and the positive 3 cancels out on the left hand side, leaving us with 12a is equal to, we have some similar terms in here, negative 11 plus 3. Negative 11 plus 3 is going to be equal to negative 8 plus 10a. Since we have a terms on both sides, we're going to take care of that in this next step here. We're going to subtract, or we'll add negative 10a to both sides of the equation. To both sides. We can either say we're going to add negative 10a to both sides, or we can say we're subtracting 10a on both sides. Both mean exactly the same thing. So we have 12a minus 10a is equal to negative 8 plus 10a minus 10a. As you can see, we have added negative 10a to both sides of the equation. The positive 10a and negative 10a cancels out on the right hand side, leaving us with negative 8 is equal to 12a minus 10a. Since the variable terms are the same, we can combine them as if we are combining whole numbers. 12 minus 10 is equal to 2a. Since we want to find the value of a, we'll try to get that in this next step. We're going to use the multiplication property and then try to find the value of 1a. Multiply by the reciprocal of 2, which is 1 over 2 on both sides of the equation. Both sides of the equation. And what do we mean by that? We mean that 2a times 1 over 2, we are multiplying by the reciprocal of 2 which is 1 over 2, because when we have a number and when we multiply the number with its reciprocal, the product is always going to be equal to 1. That is the reason why. And we want to find the value of 1a is equal to negative 8 times 1 over 2. And therefore now, as you can see, the positive 2, the 2's in the numerator denominator cancels out, and we are left with a on the left hand side, which is equal to 8 is the multiples of 2, so therefore 2 times 1 is 2, 2 times 4 is 8, and therefore the value of a is equal to negative 4. We got the value of a. We want to be able to check our work, and that we will try to get that in this next step. Step 5, we'll check our work. How do we do that? We're going to substitute the value of a into the given expression. The given expression for us is 3 times 4a minus 1 is equal to 4 plus 5 times 2a minus 3. Wherever we see a, we'll substitute negative 4. 3 times 4 times negative 4 minus 1 close parenthesis is equal to 4 plus 5 open parenthesis 2 times negative 4 minus 3 close parenthesis. We'll simplify this. So as you can see here, 3 times negative 16 minus 1 is equal to 4 plus 5 times negative 8 minus 3. So 3 times negative 17 is equal to 4 plus 5 times negative 11. So 3 times 17 is equal to negative 51. That should be equal to 4 minus 55. So negative 51 on the left hand side is equal to, when we simplify 4 minus 55, that is going to be equal to 51. Therefore the value what we have on the left hand side is exactly equal to the value what we have on the right hand side, and therefore this only goes to prove that the value of a, what we have obtained as equal to negative 4, is exactly correct. So this is the way we want to solve linear equations of the form ax plus b is equal to cx plus d using these properties, using this addition, subtraction, multiplication and division properties. If we have to use these properties multiple times, we will use them. It doesn't matter. There is no restriction that we need to use the property just once. We can use it as many times as possible, and then that is the way to solve these types of problems. In my next presentation, we shall look at some more examples to see how we can solve linear equations of the form ax plus b is equal to cx plus d.